Okay, welcome everybody. We're going to go ahead and get started. So you have found your way into the August meeting of the University Lowbrow Astronomers. My name is Charlie Nielsen. I'm the club president and seemingly have been, I think, since pterodactyls were around. And we have a few other club officers here too, and we'll take some reports from them later. But as our tradition is, we always have our guest speaker first, recognizing that some people may just be wanting to see our guest speaker and aren't particularly interested in the business meeting afterwards. And I would certainly understand that, although it is pretty enlightening, I guess. But anyway, so I give you a chance to cut out after our speaker. So, and also keep in mind that we are recording this and we'll be uploading to Zoom later on tonight or tomorrow. Our speaker tonight is my honor to bring you, actually, I have to credit our online coordinator, Jeff, for bringing us Tamas. He thought that this was a really excellent point since we're approaching a solar maximum to talk about the sun and space weather. So we're hoping this is actually very timely. Dr. Tamas Gombosi is a U of M Distinguished Professor of Space Science and an endowed professor of engineering. He is the director of the Center for Space Environment Modeling, professor of climate and space sciences and engineering, and professor of aerospace engineering. A native of Hungary, Tamas Gombosi was educated in theoretical physics at the, if I say it's Lorand Etvos Institute in Moscow. Early in his career, Tamas was a member of the scientific staff of the Central Research Institute for Physics of the Hungarian Academy of Sciences. And in 1985, he joined the faculty of the University of Michigan. And of course, we're pleased that he did that. Tamas is married to Esther Gombosi, who is here, by the way. They have two grown children, Judith and Zoltan, and both of them are alumni at the University of Michigan. Go Blue. His scientific contributions span from planetary exploration to theoretical space plasma physics, to kinetic energy and generalized transport equations, to global simulations of space plasmas. Dr. Gombosi participated in several exciting space missions, including the Venera 9 and 10 Venus orbiters, the Vega mission to Comet Halley, the Dynamics Explorer mission to explore the upper atmosphere and ionosphere, and the Pioneer Venus mission. More recent space missions include the Cassini-Huygens mission, as you know, that went to Saturn and its moon Titan, the Rosetta mission to a comet, the Stereo mission to explore solar storms, and the magnetospheric multi-scale mission. Tamas is on so many U of M national and international committees that I simply don't have time to list them all. The same can be said about his numerous publications. He is considered the authority on space weather, and Dr. Gombosi is literally an international authority on the solar wind. And as I had mentioned earlier, that's what Jeff was thinking when he recruited Tamas, and we're glad he did it. And with that, enough of hearing me, I'd like to bring up Dr. Gombosi.
Thank you. I barely recognize the person you were talking about. Jeff is, Jeff worked for me for 3 years, about 3.5 on Cassini and Rosetta. And he instructed me to start the presentation by talking about myself, my career a little bit, because he's absolutely right. It's quite unusual. So with that,
and I probably did not pronounce his name exactly right, but he said as long as I got the booze part in Gombosi.
That's true. So I was educated in theoretical physics in Hungary, as it was mentioned. Chuck mentioned, Charlie mentioned, I don't know how to call you.
Sure.
Charlie. I was a postdoc at the Space Research Institute in Moscow, and actually I was the first foreign postdoc there, which gave me a lot of attention. I was the guinea pig so to say. My main scientific contributions were just enumerated to a very large extent. I have a personal website. I have a biography, family history book, which was published by Amazon. And I wrote a manifesto of a space scientist, which basically summarizes my philosophy to do science. So if someone is interested, you can look those up. And the picture here is characteristic of me. The Hawaiian shirt was actually bought in Mexico. Let me start with my postdoc here in Moscow. As I said, this is the picture of the Space Research Institute, which is a combination of JPL and other space flight centers. In Russia, that's the main institute that works on space research. And when I arrived in the Stone Ages to Moscow to work as a postdoc, my main mentor was Konstantin Gringauz, who is also called Mr. Beep Beep. He built the radio which broadcasted on 10 meters on Sputnik 1. And he was the last person to touch Sputnik 1 before launch. He was very proud of this. The director of the institute was Roald Sagdieyev, who is now in the US, lives here in Maryland. And my main mentors were Pavel Eliasberg, who I will talk about in a few words, Vitaly Shapiro, and Albert Galeyev. So in 1977, I visited the US. That was my first, Gringauz was a winner of the Lenin Prize. It's the highest civilian award it was the highest civilian award of the Soviet Union. He was very proud of it. He got it for his accomplishments in space science. And my other mentor, big mentor there, Pavel Eliasberg, was basically kicked out of the Soviet military. He was a colonel in the Soviet Red Army, a brilliant mathematician, and he was responsible for the navigation of the first Soviet spacecraft. And when he missed the moon, it was blamed on him. He was lucky that he was not sent to Siberia. As a punishment, he was sent to the Soviet civilian space program, where he discovered me and mentored me. So Gringauz, they both had big egos, of course. So Gringauz convinced the director of my institute in Hungary to send me to a big international meeting, which was in Seattle. I was about 33 at that time. It was unheard of for Hungarian young scientists. So I went, and the Soviets basically tasked me to give the prime scientific talk about the Venus orbiters. These were the first orbiters ever of another planet. So that was a very, very big deal. And this was a couple of years before the US launched the Pioneer Venus mission. So the US scientists were very interested, and they were intrigued that how come that this crazy Hungarian kid is giving the primary Soviet talk. So I got more attention than I deserved. And there was a guy who turned out to be a professor here at Michigan. His name is Andrew Nagy, who approached me after the talk and started to talk to me in Hungarian. And then he invited me to come to Michigan as another postdoc to work on Pioneer Venus. So that's how I got here. a taste of politics after I returned from Moscow. Sergeyev, who was the director of the Space Institute in the Soviet Union, mentored me, and he used me as a contact between the Soviet space science and the US space science, because I had connections in both countries. And as Sergeyev's representative, I gave several public talks in the US. In 1982, that was the highlight of my celebrity career. I was originally, Carl Sagan invited Sergeyev to give a first public talk about the Venus Halley mission, while the Soviets were preparing to go to Comet Halley, and the Americans were not, so there was a lot of interest here. So I was invited, and because Sergeyev couldn't come, he sent me. And these are my celebrity photos. I gave a lecture at the Planetary Society. The two introductions to my lecture were given by Isaac Asimov and Carl Sagan. And then I gave the main talk. And I, with my obnoxious style, I couldn't resist pointing this out. So this really endeared me with both Asimov and Sagan, actually, literally, because they just loved the teasing. And you can see Asimov is talking to me after the talk. A year later, Hungary hosted an international conference on astronautics. And this was right after the Soviets shut down the Korean airline. But at these conferences, it was customary that both the Soviets and the Americans brought their most famous astronauts. And this was right after Svetlana Savitskaya and Sally Ride flew in space. And they were planning a number of joint appearances. But because of the Korean airline, the US delegation canceled all joint appearances. Now, astronauts are not selected and trained to be humble. So Sally Ride approached me and she said she would really like to meet Svetlana privately because they had so much in common. So I arranged a private, quote-unquote, secret meeting. But of course, all the Soviets, the Hungarians, and I suspect the American delegations, everyone knew about. And I am still surprised that, the spies didn't kill each other. We met at the home of the Hungarian astronaut, Bertalan Farkas, who is in that middle. And I was translating between Sally and Svetlana. And Sally was very, very grateful and a good friend till her death a few years ago. So this is my claim to fame. Jeff, I did my homework. So now let me talk about space weather. Space weather is my work and my hobby. Space weather is a relatively new term. It was invented some 30 years ago. And it refers to conditions in outer space, which starts, can I test the audience like students? Who knows what is the Kármán line?
62 miles.
Or precisely 100 kilometers.
100 kilometers.
147.36.
The Kármán line is the official beginning of outer space as defined by the UN. There is no scientific rationale. So, they just defined it. We can define anything. So conditions in outer space that impact human technologies or human life. That is what is space weather. And there is a lot of analogy with terrestrial weather, of course. And all space weather can be tracked back to the sun. Space weather is generated by the sun. So here I show, this is actually a composite image of the sun, where they basically show the so-called active regions, which are the bright spots on the sun during a solar cycle. So there are two major phenomena, and I don't know exactly your background, so some of you may find this part pretty boring. There are two solar phenomena that lead to major space weather events. One is called solar flares, and the other is called solar coronal mass ejections. And if you know a little bit of terminology, you can guess what it is. Flares basically are optical brightenings on the sun. Coronal mass ejection, as the name says, when the sun had too much to drink yesterday and today is barfing. And material is coming out on all orifices. So the left, the green image shows a solar flare, a pretty strong solar flare, and it really is a short-term optical brightening. That's what flares are. And the right is taken by the SOHO spacecraft. It's a CME, or coronal mass ejection, which is shown by a so-called coronagraph. Everyone, I hope, heard about coronagraphs. These are optical imagers of the sun with an occulting disk in the middle, so that they occult the sun itself out. It's like artificial eclipse. Okay, the only difference is that the Earth in a real eclipse is a much better shield. When you put in a disk in an optical instrument, it has to be about 2 solar radii. It has to cover, otherwise you get too much bright light slipping into the instrument. So you see that dark disk in the middle, that's the occulting disk, and the white circle is the actual size of the sun. And what you see is that when the eruption is coming exactly at you from the sun, so when it will directly hit the Earth, then it looks like a halo, because you are looking into the occulting disk. So the mass which is coming out at an angle from the sun will appear on all sides of the occulting disk. So when we see nice, huge coronal mass ejections like this one, then we know that something will happen at the Earth 3 days later, because it takes about 3 days under normal conditions for the mass from the sun to Earth to travel. However, the biggest, absolute biggest CMEs can be here in 14 hours, because they can travel 2,000 to 3,000 kilometers per second, 10 times faster than the solar wind. So why do we care? Because these flares and coronal mass ejections can impact, as the definition of space weather says, technological systems or humans. And this slide just shows a few, and the most important from our perspective, it impacts the power grid. That's the biggest danger. And I will show you there was an event where the power went out in Quebec French speaking, they deserve it, for 14 hours. And guess what? There was a baby boom 9 months later. I'm not joking. Of course, it can affect spacecraft. It can affect telecommunications because now all communication goes through spacecraft, GPS accuracy, long pipelines, especially north-south pipelines. Think of the Alaska pipeline, which can be basically, if there is a little leak, it can be ignited, and so on. So space weather can have huge impacts. And this is just a nice summary. Aviation, airline crew and passengers, especially those who fly on polar routes, can get large radiation, relatively large radiation doses. I have an anecdotal story about this. A friend of mine works at Livermore National Lab, and he works with some strange nuclear materials. So he has to wear a dosimeter all the time and turn it in every 2 weeks. He came home from Europe to San Francisco. It's a polar route, turned in his dosimeter. An hour later, he got a phone call. Where the hell have you been? Pipelines I mentioned, GPS errors, of course, especially for the military. It can be, when you want to send down a missile on a chimney, the accuracy actually matters. Satellite drag, because when the atmosphere heats up due to increased ultraviolet radiation, it expands, the density increases at spacecraft altitudes, and spacecrafts can have much, much shortened lifetimes due to drags, spacecraft anomalies, communications, power grid. Aurora is just beautiful. It's anthropogenic in the sense, or space weather in the sense that we love it. Astronauts, of course, and there is science. By the way, there is an academic report which estimates that a huge space weather event could cause a couple of $1 trillion of economic damage. So it's not nothing, even by US Congress's sense of economic consequences. So this is just one example, the power grid. I was talking about this March 13, 1989, the Quebec power grid, the whole state went dark for a long time. And these inserts show the damage to the transformers. And these are very expensive, individually made transformers. Each piece costs about $20 million. And it's not even the money. You cannot stockpile them, and it takes 6 months to make one. So if you blow it, it takes 6 months to basically restore everything. So it's a big deal. Astronauts. The left panel shows the kind of radiation what we observe in space. And the low energy radiation, and this is in mega electron volt units. What you need to know that spacecraft, the space station, which is the safest place for astronauts, has about a 15-gram aluminum equivalent wall at the at the strongest part, the best shielded part. And the yellow variations show the kind of variations what we have in, for instance, solar radiation. Because of the compressed scales, the yellow is about 5 orders of magnitude. So on the right-hand side, I couldn't resist showing this beautiful image of a dying astronaut. But if you have good eyes, not like me, then you can see that the lifetime radiation limit is OSHA for an astronaut is less than 1 sievert. Now, those who work with radiation or radiation oncology know that sievert is a pretty darn big unit. Here in Earth, we get something like 1/100th of a sievert, 1/100th of a millisievert, I'm sorry, a year. So it's even an X-ray, a chest X-ray is 0.1 millisievert. The Chernobyl dose that killed the people was about 1,000 millisieverts. Now, an astronaut's lifetime limit is about 700, depends on age and gender. So someone sooner or later will sue OSHA because of gender discrimination and age discrimination. But the point is that if you would send an astronaut to Mars, to a 1,000-day trip, which is typically how much it takes to go there and come back, and just spend the minimum time at Mars, you would way exceed the OSHA lifetime limit. So the US cannot legally send astronauts to Mars. So I'm curious how NASA will solve this. I'm sure they will. There was the Apollo 16 and 17 missions in 1972. 16 was in April, the 17 mission was in December. And astronauts walked on the moon in spacesuits. The spacesuit is 0.5 gram of aluminum. So even moderate radiation goes through. And there was one of the biggest solar flares and eruptions in August, what we ever observed. So if that eruption would have happened a few months earlier or later, we would have had the pleasure of astronaut funerals, which is bad for PR.
And for the astronaut.
Well, yeah, that too. So how are we observing and trying to mitigate space weather effects? First of all, there are a lot of ground-based observatories, and NASA has a fleet of heliophysics observers. It's actually a pretty good fleet. There is only one problem. We don't see the dark side of the sun. Well, officially it's called the far side of the sun, but in my profession, we just call it the dark side. And you need to see the whole sun because it will rotate in 27 days. What is occurring on the backside will hit us. There is no way out of it. So the sun has a solar cycle, and I guess most of you know about it. In 11 years, the solar cycle was discovered hundreds of years ago, at least 200. And it means that dark spots and active regions vary with an 11-year variation. So every 11 years, there is a solar minimum, and there is also a solar maximum, as it was pointed out by Charlie and Jeff. So this is just a growing up and getting old photo montage by the SOHO spacecraft. It's actually, I really like it. So what is the physical reason for the solar cycle? I'm sure some of you know it. This is how the sun rotates, and the lines what you will see are magnetic field lines. It turns out that the equator, the solar equator, rotates faster than the poles. So the magnetic field is wound up on the solar surface, and eventually it becomes so complicated that these magnetic field lines get distorted, and some loops can poke through the photosphere and be visible. Not the magnetic field, but the material that the magnetic field contains. So what happens when these magnetic field lines comes through the solar surface? This is what the so-called solar sunspots and active regions basically mean, where the magnetic field plunges through the solar surface. Those regions look dark in images, basically because the plasma is colder there. The colder plasma is darker because it's less radiative. So first of all, we know that the sunspots always come in pairs. And now we know why, because the magnetic field goes up, has to come down. And magnetic activity, which is the cause of space weather, is focused in regions where the magnetic field is coming through. So that's basically the reason behind the solar cycle and solar activity, and by extension, space weather. The first observed space weather event was observed in 1859 by Richard Carrington, a British astronomer. He actually became the Royal Astronomer. At that time, he invented the best coronagraph or coronal observations ever. He had a telescope, pointed it to the sun, and projected to a white sheet of paper. And then with hand drew around what he saw. It works. And there you see it. That was Carrington's drawing of the active region, and he had no idea that this active region will blow up in a day. So by sheer luck, the first observation of solar sunspots with detailed telescopes generated the biggest solar storms ever observed. So at that time, the most advanced technology was the telegraph. You see a telegraph station here. The telegraphs stopped working and started igniting the paper. Sparks came out, and there was a telegraph line between Boston and I think Portland, Maine, not Oregon. And the telegraph for hours worked on celestial power. They completely turned off the batteries because there was just so much electricity in the environment that the telegraphs could work freely. At that time, there were magnetometers all over the world, not as many as today, but quite a few. And this shows the magnetometer measurements in Bombay, where today is Mumbai, India. And this drop, I'm sorry, this drop here is the largest magnetic drop ever observed. So Carrington was lucky. And of course, this was a huge coronal mass ejection. And less than a day later, after Carrington's observations, the telegraphs went haywire. There was aurora in Miami, and so on. Space weather is also dangerous. In 1967, remember, well, as I look around, most people look mature enough to remember 1967. That was the jab, don't brag. That was the famous Arab-Israeli war. The world was full of political tension. That's when the Red Sea was closed off to Israeli shipping. Israel had a preemptive strike. It was in May of 67, okay? Then, of course, in June, the war broke out, the Six-Day War. But in May 18, a funny solar active region appeared. This is the one which is circled. A few days later, the US early warning radars went black. Now, if you remember Cold War, jamming the early warning radars was a casus belli, cause for war. So the Pentagon went to full alert. The US bombers were actually in the air because that's protocol, but in US airspace. And that was fortunately the time when the Pentagon started regularly observe the sun. And there was a very smart colonel, not the general, a colonel, who basically said, let's wait and see what this means because the sun is very suspicious. Well, it turned out that there was a huge solar coronal mass ejection, and the sun played games with us. Fortunately, war didn't break out. The B-2s returned to base, and we are still alive. It is. October 2003 is one of the most famous period of time in space weather research. In a period of about 10 days, there were 14 so-called X-class flares. Now, flares are categorized just like earthquakes. And when you move up by a letter, that's a 10-fold increase. So it's a logarithmic scale. Each class, there is A class, which is nothing, B, C, M, and X. There is nothing above X. Once you hit an X-class flare, it's big. Now, I marked the flares, the X-class flares on this plot. There were several X1, which is barely an X-class. There was an X17 on October 28, which was a very big one, and it directly hit Earth. And there was an X28 in November. Fortunately, that was on the limb, which means that it went 90 degrees from Earth. So it didn't hit us, but the X17 did. And I am showing the video from the SOHO spacecraft. And you can see that the SOHO spacecraft detected the coronal mass ejection, and everything is going just great as it's supposed to be until some noise appears in the detector, white noise. Let's wait and see. And basically the images are useless. Here. Who can tell me what is it? Solar energetic particles hitting the CCD. Lots of protons, yes. Yep, but pixel-wise, because these are protons. Yep, so this was, individually, these were not the biggest events, but together, and we call them Halloween storms, because scientists are nuts, and we like to give stupid names to anything we can to. So these are some of the Halloween storm anomalies, spacecraft anomalies. I would like, we lost a couple of spacecraft. All operating spacecraft during this time had anomalies. That's not without exception. These are just the big things. My favorite is the Murray instrument. Murray was a dosimeter sitting on Mars because Mars, NASA wanted, it's continuously preparing for a human mission to Mars. And NASA wanted to know the radiation environment on Mars. So they created basically a radiation measuring instrument, which failed. It got so much radiation that the radiation detector failed. I mean, this is my favorite. Yes, exactly. Yeah. So space weather, talking about the political side, the important thing, money, because everything ever do costs money. So in the 1990s, several US agencies, especially the NSF, the National Science Foundation, started to realize that space weather is a real issue and we need to deal with it. So NSF started to enroll other agencies. By the early 2010s, the concern percolated up the food chain, and even Washington politicians started to worry about it. I will talk about it a little later, if there is later. So let me speed up. Anyway, so by the late 2010s, space weather rose to the presidential level. And now there is a Pro-SWIP Act, which is basically federal law, which instructs NASA, DOD, NOAA, NSF to basically play together in the same sandbox and don't spit at each other. So space weather is really now at the presidential level. That's what I want to say from here. Here at Michigan, space weather research, without knowing the word space weather, started in November 1946. You may or may not know that the US was launching the captured German V2s up to do scientific research. V2 number 13, which was launched in November, carried two Michigan instruments. One was a Langmuir probe, which measured the electrons, the plasma. The other was basically a neutral composition instrument, very primitive, I mean, today's standards. But these two instruments were built by the group which eventually emerged to our department. In the 1950s, there were very sophisticated Earth orbiting upper atmosphere ionosphere instruments built at Michigan. In the 70s and 80s, we built a bunch of planetary instruments. Basically, Michigan instruments visited every single planet, plus comets, as Jeff knows. On the modeling and simulation side, in the last 25 years, we developed the so-called Space Weather Modeling Framework, which is a world-leading software framework to simulate the space environment. And we are doing very well. We are funded by NASA, NOAA, Department of Defense, and the NSF. And I will show a couple of videos. This is the first one. We simulated using solution adaptive grid, the coronal mass ejection from the sun to Earth. This is a two-dimensional cut through a three-dimensional numerical solution. The black sphere is the sun, and the scale on the bottom is in solar radii. So this shows the first 15 solar radii, and the white lines are magnetic field lines. So here is a mass ejection coming out, and 60 solar radii is Mercury. So it passes Mercury, reaches 1 AU, which is 215 solar radii. And at that time, here, we overlay the grid. We use adaptive solution, adaptive grids with 19 resolution changes. So 2 to the 19 is the ratio of smallest to largest cells. And then it shows the impact on Earth. This really shows, first of all, how insignificant Earth is, tiny.
It's true.
And second, it also shows that no matter how insignificant we are, we can be hit hard. Now, this is how a scientist makes a video. In 2010, the Hayden Planetarium at the American Museum of Natural History decided to create a planetarium show called Journey to the Stars. And they used about 3 minutes of the 20-minute show to show our numerical simulations of a coronal mass ejection and impact on planets. Now, this is what a professional Hollywood-style visualization looks like from our simulations. Since this planetarium show was narrated by Hoppy Goldberg, we are not allowed to use the sound. So I replaced it with Hungarian music. For those who can identify the music, I offer extra credit and a t-shirt from Charlie. That's the CME. We included the interaction with Saturn because we did that simulation anyway. Since we participated in the Cassini mission, it was a freebie. The Hidden Planetarium was so careful, they got the CAD from JPL for the Voyager. They really wanted to be as realistic as possible. Art. No, it's all artificial. Yeah. But it looks good. So that's the difference between professionals and amateurs. Yes. In the final 5 minutes, I'm sorry, I want to talk about the other part of what I was planning to talk, anthropogenic space weather. And this is what people don't know much about. Anthropogenic space weather is a code word for high altitude nuclear explosions. And the US and the old Soviet Union were the culprits. And this is one of the reasons why US Congress, the president, and the military are so interested. And the real reason is, and I will show it, because space weather mimics certain aspects of these nuclear explosions. And yeah, and so after the Sputnik shock in '57, the US, not many of you were adults at that time, the US was very worried about Soviet ballistic missiles armed with thermonuclear weapons. And Los Alamos and Livermore, the two big weapons labs, they actively were thinking about how to defend the country. And one of the ideas by a guy named Nicholas Christopoulos, a Greek, was that maybe a high altitude nuclear explosion can create an artificial radiation belt that can fry the Soviet missiles. Of course, the US immediately wanted to try it. No stupid idea goes unaccepted. So this is the high altitude nuclear explosions by the US and the Soviets. The most important is the so-called Starfish Prime. I don't know how many of you heard about it, but you should. Starfish Prime was a 1 megaton hydrogen bomb exploded at an altitude of 400 kilometers. And that is the culmination of anthropogenic space weather, and I will talk about it. So what's the similarity and difference between natural phenomena like a lightning and a so-called EMP? Many of you heard the word EMP, electromagnetic pulse. And HEMP, it's not what you think, or not what you would like to think. HEMP stands for high altitude electromagnetic pulse. Okay, so the red line here is the HEMP impact of the generated electric fields that kill technology, basically. And the green is a natural lightning. First of all, a HEMP looks like a continent-like lightning. Everything at the same time, shorts. Second, the horizontal axis is logarithmic. So the HEMP peaks at 10 to the minus 8 seconds, 10 nanoseconds. And the electric field is humongous. No electric circuit breaker in the world is fast enough to break the electric circuit and protect. None. The lightning peaks at about microsecond. And there are zillions of circuit breakers that work that fast. So this is E1, the so-called early time phase. This is where the biggest impact happens. The second phase is the so-called intermediate time, when there is a lot of secondary radiation. But the electric field is 3 orders of magnitude smaller. So it's much less dangerous. And then there is the late time, which is actually the same as space weather. So space weather research is in some respect the civilian expansion of EMP research, what national security desperately needs. Because EMPs can be created, it's not the Soviets, it's the small rogue nations, Iran, Korea, North Korea. I mean, they can do EMP with what they have. And that's the concept. I mean, I fully understand it, but, and you know, that's why they are very interested in supporting our type space weather research, because first of all, we are training students who they can hire because they know what they are doing. And second, because some of the poor scientific results are very relevant for them. I mean, let's not kid ourselves. So this is just a map, a world map of magnetic perturbations. I think this was 2 minutes and 51 seconds after Starfish Prime. So this is 3 minutes after the big bomb was exploded at 400 kilometers. It was, of course, above the US Marshall Islands. And you can see the red lines are the closest. And the red lines, these are magnetic perturbations on the surface of the Earth, which basically translate to electric fields and space weather impacts. So 150 nanotesla, no natural thing can cause 150 nanotesla. It's huge. Now, even in Europe, which is as far as it gets, they were talking about tens of nanoteslas, which is, standard large geomagnetic storms. So these are potential HAMP impacts on technology. The power grid, it will be wiped out pretty much. Cars, all the modern cars that work with microprocessors will die because they don't run without the microprocessor. Even your Mazda. Pacemakers. I don't know much about pacemakers, but there are the unshielded ones, and even the shielded ones are not, I mean, they probably will survive. The unshielded ones definitely will kill you. Mobile devices, all cell phones will die, which is not a problem because the cell towers will die before that. So there will be nothing to phone. And airplanes, the modern airplanes use electronics for everything, like flight control. All the modern planes will fall out of the sky. The old planes may not. Radiation belts. Here is a comparison of radiation belts a few months. The top half was observed a few months after starfish. The bottom half was observed by the Van Allen probes. So it's a few years ago. You can see that close to Earth, there is that red region. So even months after starfish, there was an artificial radiation belt inside, very close to Earth, which is still dangerous for everything that goes through. And finally, this is my last slide. This is the effect of a HAMP burst altitude. This is one single megaton class bomb at 400 kilometers will create a big EMP over the entire United States. If it's exploded at 30 kilometers, then it's only central US. But why would they explode it at 30 if they can explode it at 400? It beats the purpose. So, is the sun or humanity more dangerous? You decide. Thank you. And I'm sorry, it was a little longer.
We're not sorry. Thank you, Tomas.
Any volunteers to identify the music? Esther, you are? No. My wife is Hungarian, so she knows.
One Hungarian thing, Hungarian rap.
This is, no?
No.
That's half a point.
Doesn't.
So it's Brahms, Hungarian dance is number 6. It's Brahms.
We did get a couple of questions online. The first one's from the Zoltan.
It's my son.
I don't know.
He is in deep trouble.
Since the magnetic field of the sun gets disrupted over time, creating the dark spots and eventually leading to solar minimum, how does the magnetic field return to normal once again?
Good question. Smart boy. He probably inherited it from his father. There is a so-called solar dynamo, which regenerates the magnetic field. And that dynamo works. There are two, I don't want to go too much into solar physics, but it's a combination of the differential rotation so that the equatorial region rotates faster, and the so-called convection, when heat and magnetic energy is like a conveyor belt at the boundary of the convection zone, the uppermost layer of the sun. At the boundary of the convection zone, it's loaded with thermal energy, and it moves up because it's warm and rises. Once it reaches the surface, the photosphere, it basically radiates its energy, cools, becomes heavier, and sinks back. And then it's reheated. So the solar energy, the thermonuclear fusion inside the sun, is the reason why the solar magnetic field is regenerated.
In the event of a coronal injection, how long is you're exposed to the increased radiation?
Days. Typically days.
So at speed, the width of this coronal injection can just be measured.
No, it's the two are independent. The speed of the coronal mass ejection is a few thousand kilometers per second. If you calculate the energy of a proton with, let's say 3,000 kilometers per second, that's about 100 eV. So it's very low. There is acceleration, particle acceleration near the sun, and particle acceleration on so-called shocks, because the coronal mass ejection it's like a supersonic jet. It's moving faster than the sound speed. So it creates a shock wave ahead of it.
So the shock wave lags behind and that creates the increased amount of
The shock wave translates part of its energy to individual particles. And this is called shock acceleration. And then you can get, with shock acceleration, you can go up to hundreds of MeVs. So pretty high energies. Yes.
So the implication, very basic understanding of my family. The implication is that based on this slide, that the sun is more than. So how do we control it? And more importantly, why we
I don't have an answer. The sun we cannot control, we can observe and we can forecast.
What we do, we're saying that it's really not really contributing to this stuff. This is the cause, based on your understanding of the law. But what are we doing?
Well, space weather up to a point can be mitigated if you have early enough warning. Sorry, I go away from the microphone. For instance, you can turn spacecraft to safe mode. And when the spacecraft is passive, then the damage to electronics is much less significant. Or you can, the power grid, the US power grid is a mess to begin with. So if the country would invest enough, we could make the power grid much more resilient. Congress is not willing to spend money until shit hits the fan. And then it's too late. That's the sad truth. You are absolutely right.
Another question back to the point.
I was just gonna say at this point, couldn't you argue that our dependency on these systems is probably more dangerous? And it's something that we probably control.
Well, crazy humans are always more dangerous in my view. And politicians, I don't trust them. I spent a lot of time in both camps, and I owe a lot to the Soviet regime. Everything I know, I learned there. but it was not a pretty picture. And the present US political situation is disgusting.
One of the,
But we still live here and now, right?
one of the questions online was, why does the auroral oval have a hole in the center?
It is because the auroral oval is formed by the boundary between open and closed magnetic field lines. And the open field lines from Earth go directly to the solar wind, so directly to outer space. The magnetospheric field lines map to the ionosphere, and there is a very narrow boundary between them, and that is the auroral oval.
Do you have a Faraday cage?
Yes.
Devices?
A Faraday cage is a brilliant idea. Build one in your house. And when the Iranians tell you that they just launched, go to the Faraday cage. Yes, but we cannot build a Faraday cage around everything.
Dr. Kurt Hillen, one of our members, says, thinking of shielding from a CME with hydrogen-rich materials, water, polyethylene, etc., shield from high-energy protons as well as they work for neutrons.
Yes. The answer is yes, and actually the design of the Mars, the human Mars probe will have, because they have to carry water. They carry the water in the walls.
Yeah.
Because that's a very good shield.
Just gotta make sure they get some before they come back.
And they replenish. I'm not the moderator.
Okay, so I have a question. What's the relationship between a solar flare or the conditions that create a solar flare and the conditions that create a coronal mass ejection? Because often when I hear about them, I hear the explanation for a solar flare, and I've learned that myself through the education history, but I don't have a good understanding of how that relates to a coronal mass ejection. Are they the same thing? So are we the one, or are they just the dynamic?
No. There are very important differences and very important connections. And as a matter of fact, till the early 1990s, people were arguing about whether flares come first and then the CME, or vice versa, or they come together. Today, we understand that they are two sides of the same phenomenon. Have you heard about magnetic reconnection?
Yeah.
So magnetic reconnection is the energy source for both. And when the magnetic reconnection happens on the sun, that's when you see a flash first, the flare. But that same magnetic reconnection energizes a magnetic bubble, which will drive the coronal mass ejection. So the root cause is the same, but one may come earlier or later. It's really just the two sides of the same coin.
So if the flare happens, is the CME going to happen?
Not necessarily. And that's the big argument. There are flares without CMEs and CMEs without flares. Magnetic reconnection is a very complicated physical process and depends on how and at what heights it takes place. For instance, if it happens down near the surface, a lot of the material that is ejected might fall back.
Yeah.
So it's, as the movie says, it's complicated.
the question for you or anybody, like what protections did scientists put in place on James Webb Space Telescope from potential space weather challenges?
None. Basically, the answer is the mirror is there. You cannot shield the mirror because then you shield the everything. Now they built the electronics is a well shielded area, but there are exposed parts and that there is just nothing anyone can do except turning it off, which helps. You know, when there is that's why space weather forecasting is so important, not only for the space telescope, but for the power grid. You want more? Yeah.
I can offer. Okay, okay. So here at the observatory, we do a lot of solar observing, we do white light observing, and we'll soon have some H alpha telescopes to look at the chromosphere. So we're always talking to people about sunspots and we talk to them about how they we talk about the, you know what, I lost the question. Just threw away my head, so I'll save it later.
Okay.
Sorry about that.
No, that was solar flare.
It was a solar flare.
Yeah. DMP from somewhere. Okay. Thank you.
Thank you. And my son was upset with me when I shared the password with him. He said, "Lowbrow, isn't that exciting?"
Before we go to officer reports, I want to see if Austin wants to talk about this telescope a little bit.
Thank you.
Oh, wait until he's done there.
Thank you, Tomas.
Thanks, Jim.
Thank you.
Thank you. Good stuff.
Yeah.
Yeah.
It's like, I've heard pieces, parts of that for like 3.5 years, sitting in the casino outside of meetings, seeing his talk when he got the award. Lifetime award, and it's like, wow, you've got to figure out. I'm gonna set my sheet up here so you can have a video. Awesome.
Oh, sorry. Sorry about it. Yeah.
I just wondered if you wanted to explain.
Oh, yeah, okay, yeah. So if you hadn't seen it before, I'm not gonna move the box much.
Yes, come on out.
Reasons you'll learn in a second. We received a very generous donation of this around 1921 Zeiss 80mm refractor. This is a almost 100-year-old telescope. It was custom made for a specific individual about 100 years ago. It stayed in this person's family up to a couple of days ago, where it was very generously given to the observatory to further use and conserve as both a historical piece to teach the history of telescopes, the history of science, the history of optics, anything we want, to use to it, but also personally, I'm also very interested in the family history of this person. So we're looking to kind of tell that story as well. This telescope relates back to a very specific mathematician named Carl Runge. And correct me, it's German if I'm pronouncing that wrong. Runge developed, along with Wilhelm Kutte, in Germany, he developed a series of numerical methods to solve differential equations. This is especially useful if you need to solve an equation numerically on a computer simulation. So I have personally written on paper and into computer code these Runge Kutte methods more times than I can count. If you talk to like a professional astronomer, physicist, computational scientist, their ears would perk up at Runge. And so this was his personal telescope. He had a friend in Germany, this industrialist friend whose name I'm still learning. Kind of like to hang around science circles, so he knew people across the mathematics and astronomy and physics departments. And he approached Carl Runge with the hope that Carl would commission a telescope for him. And that's what we have here. Now, Carl did commission a telescope for this person. And when they made a second one. And this is that. So somewhere out there, hopefully it still exists, is a sibling telescope to this. And it's in wonderful condition. I mean, you look at it, it's kind of dirty. It's been in a fortunately, very dry basement for about 20 or so years. It was very well loved by this family throughout the past century, so it was very well used. And we're excited to conserve it. So like a year from now, maybe less, maybe longer, you never know how these things go. We will hopefully have this in working condition that we will be able to share and use through with you here at the observatory.
I assume I'm gonna use the word refurbished. But that's kind of a wide definition.
So
Are you going to clean it up so that it's working and appears as it did? Or are you gonna, strip and?
in conversation with the donor, we're leaning towards conservation. So we will probably disassemble it to some extent. We will be repainting it. We don't want to restore the telescope. The telescope's actually in fantastic condition, and we really don't want to do anything yet that might be irreversible. If you do a restoration, you are sometimes making decisions that are not reversible. In conservation, we will clean the telescope. We will get it into as best condition as possible. We will make sure all the bolts and nuts that are holding the mount together and holding parts of the telescope together aren't just going to fall apart when we start using it. And we will protect the surface as is so that you can see some of the historic love that this telescope has received. There's paint chips in there. And if you sat there and worked at it, and you would make them bigger. So we don't want to make those bigger, right? We don't want to cause more problems, but we also don't want to necessarily do something that's irreversible. And to a lot of people too, seeing the telescope in its used state, it kind of contributes to its history and the storytelling that we have with it. Because if it looks brand new, it's not brand new, right? It has had a life. And so we want to preserve that life while still making it functional. To my understanding, we have not pulled the lens cell out and put it under magnifying. But it looks to be in
Glass
limited
looks
condition.
pretty good.
Yeah. We don't see fungus on there, and usually for fungal growth on lenses, you're looking for little trees, spiny things sticking around, or you're looking for little circular patches, and we don't seem to see any of that. But again, we haven't pulled everything out, so maybe that's there. Fungal growth, if you've ever had old lenses, etches right into that glass and can harm your viewing through the telescope. So we're very fortunate.
Focus are still smooth.
Yeah, focus is smooth. The finder is here. We have serial numbers on most, if not all, of the parts, so we can actually reach out to Zeiss's historic division and possibly learn more about this telescope. And sometimes the kind of records that people kept with these telescopes in these factories, I mean, we might even know the person who screwed this thing together before they send it to Carl Runge. So we're really excited to kind of explore that in the coming weeks, explore conservation and explore using it. And of course, the boxes we believe are original, and I think just displaying it sometimes as a storytelling piece would be exciting as well, because we've got a lot to talk about with this. Yeah.
Aperture, what's the aperture?
It's
80
80 millimeter. So we think it's about an f15, f16.
Yeah, it's gotta be, I believe the size of that tube for an 8 millimeter.
Yeah, which is pretty typical. Like the
Yeah,
fix is
that's
an f16, and so it's pretty typical to have these telescopes as like lunar observations, planetary observations, star cluster observations, anything where you're looking at small, high contrast objects. You would not have used this much for nebula viewings or comet viewings, maybe comets, but really this is kind of more for the high contrast stuff. Yeah, we have a mount for it. I've got a piece of the equatorial mount, but the tripod there, I'm still kind of figuring that out. That might not be the original tripod. Looking through the manual, this thing would have come with a more sturdy, smaller mount that you might roll out onto your balcony or something like that. And this, I believe, is the field mount. So this is the one you would have taken outside into the woods or something, or not into the woods, but in a field. You could kind of spike it into the ground. But yeah.
And the equatorial head is over in that box over there.
Yeah, I can pop that lid off. In a
Yeah,
minute.
that's something to see too.
It's cool.
Yeah.
And we have the original eyepieces. And most of them, I can't, there's obviously a lot of spots here that are empty, but we have eyepieces, we have, still in German, for change, ocular spectroscope. So we have a spectroscopic eyepiece here and little things like that. So
They don't make two which will sort of order like that.
no, yeah, that's not where our eyepiece is. We've got a wonderful little rotary eyepiece here as well for switching between different eyepieces. Honestly, I think this might have been a separate edition because I cannot figure out how this fits in this box. Unless it was disassembled, so
It looks kind of new compared to the rest of it too.
yeah, it's hard to tell. We have serial numbers on everything, so again, we should be able to reach out to Zeiss and learn something. They don't always have records of everything. Zeiss was a German company, and so they've gone through many changes. They've gone through many losses, especially during and after World War II. So they may know from the serial number whether they have the records at all. But that's a good place to start. And unfortunately, some of you may already be on the Antique Telescope Society mailing list. Literally the day after we got this donated, someone else reached out on that list for a slightly earlier 1904 or earlier Zeiss refractor in almost the same exact box. And it has the same exact paint job. Looks almost the same. It's about an 80 or 90 millimeter aperture. So that was kind of exciting. And someone replied to them with, you have the serial numbers, email this person. So that's our next step, is to start building the history of this thing. Outside of the family history, I think we're good to talk about it. So the person who donated this is Paul Courant. He's the provost emeritus of the University of Michigan. He was the provost a few years ago. He was the provost earlier in the 2000s. He's a professor of economics at the University of Michigan. He was part of the Ford School. His family history is fascinating. So it was his great grandfather, Carl Runge, who originally owned this telescope. Runge passed it on to his daughter, forgetting her first name, and she used it more than anybody else. And Paul actually has spoken to us about memories of her, like waking them up early at night to use this telescope. So she was a pretty avid amateur astronomer. She would have loved hanging out in the club. And then it passed on to his dad, who was a particle physicist. His grandfather was, I forget his first name, also a Courant. His grandfather and grandmother, the grandmother who used the telescope, were also in Germany in the 1930s. His grandfather was Jewish and a social democrat leftist. So 1930s was a great time to get fired and get out of Germany. Came to New York University, started another mathematics institute who still exists today as Courant Institute for Applied Mathematics. It's my understanding the place to study applied mathematics in the world. And this family has kept this telescope for 100 years, and I've only just recently relinquished it to us to sort of continue its history. So, pretty exciting. Just that family history. Paul Courant has been a very longtime supporter and board member of the Bentley Historical Library, who owns the Detroit Observatory. He was an advocate for getting this place built, so you can thank him for just having this classroom in a lot of ways. And so we're really excited for that connection as well. Paul's personal history is interesting. The telescope's history is interesting, and every connection in between is just really cool. You have so many ways we want to explore this going forward. Yeah, it's part of a growing collection we have of historic telescopes. We've got pieces from the rest of the Detroit Observatory that we're beginning to start conservation projects for. The Student Transit Telescope, the old Finder for the FITS is a Comet Seeker style telescope that we'll have conserved in the near future. So little things like that you'll start to see pop up. You know, the FITS is wonderful. We've got a lot more than the FITS, and really the biggest struggle is finding places to put them when we're not using them. So yeah.
Cool. Very cool.
Awesome.
Then if you want, I pop the lid off that equatorial and you get a chance, you might want to look at it. Yeah.
It's not touch anything, of course. It's, we're still figuring out the quality of life of these pieces. But we look forward to, in the future, unknown time, possibly using this telescope. So.
While you're doing that, I will go ahead and start our officer reports. I've got two things. One of them is I'd sent an email out, and I'm going to send another one probably this weekend yet. Early next week at latest, with more detail on the event that Dimitri had set up for us, which is up at Owasso Airport. Did I mention free food? Yeah, seriously, they are gonna feed us. But what this is basically is some kind of like a family get together fly-in where these pilots come in and they have this party thing. It's some annual thing they do. Dimitri was up there and got talking to the manager of the restaurant that's at the airport and mentioned astronomy. She got very interested and thought it would be really cool if we came up there for that and did a little star party for him. So I have since contacted her and I will be in more contact to get more details. It is about an hour drive, but we've gone that far or further before for things. So, and pardon me?
Contact you for more details.
No, I'm going to be sending more details out. I'll be emailing them out. So,
Somebody's interested.
yeah.
Should contact you. No.
Oh, true. Yeah. But obviously we need some help for this. I think we've got myself and I think Dimitri's going to be there. I hope. Did you say you were going to go? A couple other people did. Jim, I think. Yeah. And I thought maybe somebody else, but I'm going to be after you again anyway. So, and also today something was sent out about this event they're doing, Blue Moon on the Beach, I think it is, at Kensington Metro Park, and which ironically I was just up that Saturday, but anyway, they're asking for people to bring telescopes up there to be part of that, but they didn't check with us and schedule it for the 26th, same day as the Owasso event. So don't go there, go to Owasso. The only other thing I wanted to mention is that we have guest speakers up until November. Starting in November, we have no speakers lined up, and November will be here, unfortunately, way too quick. So I'm going to be asking the vice presidents if they can come up with speakers. I actually took a shot at one just a couple weeks or so ago, which did not work out. But sometimes that happens. I actually find that most of them, if you ask them more than not, they say yes, but not always. So, and I think she was moving or something, so she had a legitimate excuse. But anyway, we need speakers, and you don't have to be a VP to come up with a speaker. Ken has come up with speakers. Jeff did for our speaker tonight. So if you want to do something yourself, some of the best presentations we've had were by our own club members. So consider that. That's all I got. So I will move to Jeff.
Tonight we had, we're actually starting to settle in. For our online was like 15 people max, and the in-person was 30. So we're kind of getting this 2-to-1 ratio that's starting to cement here, which is really
including you twice.
You know that, yeah.
Was it really?
No, I think it's including me twice.
Okay, so 14.
I always get an extra one because of on the Zoom and the live. But those stats will all be posted in the next newsletter. The website continues to be loaded up with stuff. Many thanks to Dave Snyder and our newsletter editor, Amy Cantu, for continually loading more and more stuff and straightening out little things we find. We're gradually getting through, like the members only section, I think is mostly gone through, and we're starting to work through the rest of the public site to put it in the right spot in the new place. I started in on young astronomers, and I'll work with Jack to, massage that out. In my other capacity on Monday, we had the second to last meeting for astronomy at the beach. The date is September 22nd and 23rd. We found out this past couple of weeks that NASA's Glenn Research Center is going to be coming and attending as a vendor. They're going to have exhibits and kind of displays, demonstrations, etc. So yay, NASA is coming. We are going to have a large telescope field, and we're hoping that this will be the year that we can get back to pre-COVID attendance times and all that. The website is glac.org, and there's an Astronomy at the Beach tab on there. And we have a Facebook event set up. Please share it with whoever and whenever you can to get the word out. Again, it's September 22nd and 23rd. The telescope field, it is the Lowbrows always have a good contingency there. So feel free to bring out your scopes and set up.
It's a free event. The only thing is that it's a state park, so you need your state park rec pass, which they'll be happy to sell you at the door. You can get it a few bucks cheaper if you do it online at the state. I think that's a big thing. Brian Autumn is doing all the marketing on that, so you'll see more and more activities and stuff come through. We've got a full program of speakers now. And I think I can't remember his name off the top of my head, but he's the former WDIV weatherman, who's going to be talking about weather and climate and astronomy topics. That's our.
I knew his name until you said.
I know. I was like, who?
Yeah, exactly.
He also know what I'm talking about.
Yeah,
Paul Gross.
thank you.
That's it.
Yeah, we're.
Yes, but he will be there and speaking. I believe he's got the Saturday night talk, but it's either Friday or Saturday. The event starts at 6 p.m. formally and goes till about midnight. We will have some people out there, myself included, with some solar telescopes, probably around 3 to 4 o'clock. That usually gets set up, but there's only like a handful of us that bring those out, so we don't advertise it as big. But if you got a solar telescope, bring it out. You'll have people looking at it. So we're hoping.
Probably want to look at the sun even more after
Yeah.
tonight. Right?
We're hoping to get close to the 4,000 or 5,000 mark that we were in 2019 when everything the proverbial shit hit the fan. So
You got a question, Austin?
Yeah.
So I'm not from Michigan, so I can straight in my head. Does the state red pass on my sticker count as the?
Yeah,
pass?
that's the one.
Yeah.
If you paid for it when you did your license plates, then that's the sticker.
For example, if you went down 96 where Kensington is, that sticker would work for Island State Recreation Area on the south side, but not Kensington Metro Park on the north side.
Yeah, that's the middle of the thing.
Yeah, exactly,
Right.
exactly.
Yeah, they're
Separate pseudo.
yeah, they're in the Metro Park system, whereas Island Lake is on the state park system. And
Yeah.
I'm sure there's a story behind why they switched from Kensington into the state park, but the
There
state
is.
park, yeah, I can't remember it, and I'm not going to reiterate it
political.
yeah, everything is.
Yeah,
But the guy that is working with us at the state park at Island Lake is super to work with. We've got an entirely large field with not many trees on the beach, tents and all that for demonstrations. It's a nice setup. So coming out on the 22nd, 23rd of next month.
just in case you're curious, we were at Kensington for many, many, many years. And then all of a sudden, I think it was a change in management that occurred.
Yeah.
And they put all these demands on us. They wanted what was like $1 million worth of liability insurance.
It was-
They wanted all this information so they could run background checks on everybody. And I don't think that was the end of it. It was a whole bunch of stuff, and we just finally say, you know what?
We were approached by Kensington this year about some other event they wanted to run. And again, they were asking for insurance
Yeah.
waivers and insurance policies, all this, like, we're a volunteer organization. What are you talking about?
Yeah, I mean, what are we gonna do? You know?
The state park system is like, you pay taxes, you get to use the state park, done.
Yeah,
Well, one of the giggles about that, was we bring over the weekend, usually 5,000.
Yeah.
Right.
They all pay $5 or $10, whatever it was.
it's 10, yeah, right now.
So they can't figure out how to pay for insurance out of that. That was.
Exactly.
So.
Yeah, well put.
We're at Island Lake.
Yeah.
I think
Thank
that's
you,
all I
Jeff.
got to yak about now.
Okay, thank you, Jeff. Dave,
Yeah, Jeff mentioned there's working on the new website. I think we're done as much as we're gonna do with the numbers on these.
Yeah.
And switch gears to the public. So there's a whole bunch of photos and they have people from all, I don't know, and so we've got this about.
Well, one thing I do keep adding is when we get photos that come through the email and all that to go out in your membership,
I've been trying to pull those off and throw those up on the new site, so the members' photo section starts to build up. And I think long-term, we'll probably divide that into different categories. I've been tagging them as we go, so when it gets too big, then we can, split it up at that time. But, yeah, thank you again.
Thank you, Dave. And mention again, thank you very much for doing the minutes, Ken. Much appreciated. I'll move to Jim.
We had a couple of impressive events. Days, the open house was attended by close to 100 people.
Wow.
Unfortunately, it wasn't attended by nearly as many lowbrows. We needed more help than we got, but we had just enough to make it work. But when you don't have really enough, it means that you're doing a lot of yelling to let people know what they can do and what they can't. And that's just not good for the people yelling, and it's not good for impression on the public. We might have. Leading into Saturday night, we have another open. Multi is overwhelmed by the public, because the meteors will be pretty much gone, but we do need operators, math, even have help reading people as well as scopes on the field. The other event was this past Wednesday. We had an almost perfect night. Skywise, and 9 of us showed up, almost twice as many that showed up for their open house. So, we make these plans months in advance. Everybody knows that when they are, you would think that once a year, every member can make time in their life to help out one Saturday night. The most we ever have, every Saturday night in the schedule is clear, it's going to be 18. Usually, if we're lucky, half of that wiped out by the one. So, maybe 10 nights a year, we need help each month. And to the point where start getting out the whip, and when you sign on the dotted line and pay your $30, you're signing in blood to be out of each month once a year. But that would take an adjustment to the bylaws.
We could do that.
We could do that.
A lot of boat clubs, they have some mandatory service and all that. And I mean, coming out to Peach Mountain once a year is not that big of a commitment. And it would help out if we schedule people out, like maybe that's not bad.
Maybe we should have a draft or something. We'll hold a draft.
I've been
Make it
putting
fun.
Together a lot of this, Steve, Jack, and 1 or 2 other people. I've gone to the open houses in September. So if they're gonna happen, it's gonna be people in this room and online for this meeting that are gonna make it happen.
And that's a good point, Jim, because I can make tomorrow night, but September is a mess for me.
Well, it's a mess for everybody in the club, like I said. I'll be going, Adrian and I are traveling to Open Text. And there are other star parties that are happening that same weekend. The first weekend and the second weekend, the Great Lakes Stargaze, the Black Forest Star Party in Pennsylvania. Those are 2 big ones for the people in this area.
And the week after is astronomy at the beach.
And
Yeah.
Big thing.
at the end of the month is astronomy at the beach. Fortunately, this year, it does not conflict with, Okie-Tex, so hopefully.
We did that on purpose.
Yeah.
You did that for me?
Yes, we did. Adrian's on board too, so.
Yeah.
I'm the newest member, I believe. Earlier this week. I paid my $30 in blood. I come
All right.
right out.
And you didn't know about the draft system, did you?
So I can definitely help out. I live 10 minutes away from Huge Mountain.
That's
So,
good.
I'm sorry, what's your,
There'll be details.
Yeah.
There'll be an email going out about when the gate will be open, and, show up as soon as you can in the evening.
Yeah, yes.
You gonna be there, Ken?
Yeah, I'll be able to make go this month.
Okay, this one.
I'll try to Saturday, yeah.
I'm sorry, what's your name?
Brandon.
Pardon?
Brandon.
Brandon, okay, so I thought I'd met you before and everything. What I want to know is, where'd you get the t-shirt?
From a Lowbrow.
Okay, because we haven't had that one for years.
Yeah, it was nice.
Show everybody.
I had that one too. And I put this one on specifically because I thought this was probably.
Yeah, that goes way back.
Then I saw that, it's like, that's.
Yeah.
There was a member, there was a member that passed away a few years ago.
Everybody.
I was at a garage sale.
Ah.
Up here on River Drive, I think.
Oh, John Coslin.
Yeah, and I walk in, I see stacks of Sky and Telescope magazines, astronomy magazines.
Yeah.
And really cool Hale Box t-shirt and these, so that's where.
Wow.
I picked it up. And
Very
that's
cool.
how I found out about you guys.
Very cool.
Was through that branch.
Everyone should know that these open houses particular are opportunities to learn to run the McMahon telescope. If you make advanced arrangements to learn to run the 17.5-inch so.
I gotta run through that class again. Because I forgot some of the details on it.
Oh. Charlie, we'll all set up.
Oh.
So we're going tomorrow.
Yep,
Yes, tomorrow. Yeah, at one point I didn't have opening and closing. But that was the old controls.
Still got a crank.
I know.
Yeah.
That. I have pain, I haven't done this, I know, it's one thing, I'm really back.
It's a different control system, but every single person.
I mean, I'm talking about the one that, like, Mike built.
Oh, okay. It works the same, it's just that all the electronics is more modern.
Sort of. The other one was a little bit. I don't know.
Hmm.
The old one. was the new one, nicer than that, new guys. Yeah. Old one was there, that part is not the same.
Yeah,
We have put same surface on it. You could, push two with nice.
yeah.
That's news that you.
And I find a lot of times for open houses, if I'm running the McMath, I don't even use the setting circles or anything on it, because you're only gonna do a few objects for the public, and I just get them the old fashioned way.
The McMath is easy.
Yeah, yeah,
You just pick the big.
Yeah,
Easier. to-
exactly.
Ones that look good in those
Yep.
eyepieces.
Yep.
And they're, you've got the walls of the observatory, you got stands.
Mhm.
Well, here, stuff here. So, I don't know, so I'll try, I will try to be there Saturday.
Excellent.
I can't remember what else I promised to do. So. Just avoid. I'll, see what we can do.
Cool. Is that it, Jim?
That's it.
Okay, Jack.
As far as observatory goes, everything has been working well. We only have one issue that's come up. And it's working with the Arbor Davis. There seems to be some issues with certain items, how they're programmed. And then all of a sudden they will change. You gotta go back and program it. Yeah, Mike's doing that. Well, that's on the 24th. Yeah.
Oh, that's what you.
Yeah. And so we have to start looking at a little better generally, so. Probably 15 years old.
Fortunately, we're on this one.
Other than that, because of tomorrow night,
It is getting.
oh, there is the other fire.
It'll turn.
It's on, it's, on the issue of the dehumidifier. I'm just waiting to get things straight about, and I'll make an announcement about that. Someone, member of the club has offered to, buy the dehumidifier, donate it to me. Just waiting to get that straight, and I'll notify the officers, person, and everything, make that known. But, yeah, that's why I've been saying, I was surprised, and, you'll recognize the
Cool.
individual, but I mean, when we get this thing all worked out, then I'll contact the officers, make an official announcement, purchase it and all that.
Excellent.
Tight, all that too. Just want to wait to get this straightened out. Yeah, it is gonna happen. Thanks.
Cool.
You made any progress with the loan documents?
No, you know, I started looking at rewriting that, and moving stuff out. And I looked at the old ones that we originally, 2012 and some other things too. The only thing I can find out on that is we have the term the equipment manager, but there is nobody in the club that's delegated as the equipment manager.
Yeah.
There's nobody that's also that's the equipment. So the equipment manager may be determined by whoever is in charge of that, such as I've got 4 telescopes in the observatory, so if someone takes it out, I get notified and I'll take care of those. And I know there are other people in the club that have some telescopes or other types of equipment they have that they take care of themselves. So I guess that would make them the equipment manager for that piece of equipment they're taking care of. And it's things like that we have to have an agreement on, because that particular person is also be responsible for not only maybe like the delivery or loading of the scope, to make sure it gets returned. Well, I think we've got some binoculars. The one with telescope, and there's some other people I think that some of those small little kids telescopes or something like that we did at one time.
Investigate some of those knobs, that probably be a good job.
Yeah, we had it set up. I had a couple of, but we got a new one back and I straightened it. Couldn't have one out. So that's really something. That's kind of interesting. Also, to start off. Because it's a tapered mirror. It's not a regular square mirror like or round. Even thickness type. So the tapered mirror in the back. That was made in 1998, so we had this little scope, which is kind of interesting. Other than that, I'll give you the whole scope loader document. We put that in with. The other thing is an understanding on the club's website, we'll be filling all the information that comes out. The telescope and small tune and stuff like that. It's one of the Google systems in there. I think we're down to one. I think we actually had 2 different ones at one time. I think that's worked out. So just one, and those people are going to have to fill that out. Whoever's has that piece of equipment updated on the website.
We might be able to work out something with like Google Forms or something.
Yeah, you got it on there, make it on the tomorrow.
Thanks.
You got an Excel spreadsheet or something.
Right,
Yeah.
but like a sign out form or something. like
Yeah,
that.
and that's what we're doing now, so who's ever going to take over this, gonna do that. And they're going to have to make sure they fill those forms out. Date, return, stuff like that, and they're responsible. That's all I have to say right now.
Okay. And I don't see any officers in the Zoom audience. So does anybody have anything else? Don?
I got a question for Jeff. So our official website, is it going to be lowbrows.org?
Eventually, I mean, we want to keep the lowbrows.org.
It's going to be lowbrow, lowbrow.
I can't remember what the current one, I think, is lowbrows.org. Lowbrows, and we have lowbrows.club that came with the WordPress.
when we get ready to say we're done with the old site, then we're gonna point, right now, the lowbrows.org is more or less like a pointer, and it points to a spot inside the University of Michigan web structure. When we get ready to flop over, then we'll make that thing point over to the WordPress site. And lowbrows.club, we'll keep it around as long as we need to, but for right now, that's the WordPress site. But yeah, it's easy to point.
Right
that out.
now, lowbrows.edu.
No, .org. It's not, no, it's not. No, it's not. It's unish.edu /lowbrow. Right. Yeah, and that's, and that is what lowbrows.org points to. Young astronomer, yes, yes. Yeah, it's literally just a pointer, and you can make it point anywhere you like, just that you have to kind of orchestrate it so that it all works out right.
But also, actually, there's you missed that EU thing, there's probably one, but
Yeah, well,
you
that's,
have to use lowbrows.org
Yeah.
instead.
Right.
well, the UMich services are changing, and that's part of the reason that prompted us to get going on a WordPress. We looked into the university's offerings, and for right now, they are still free, but they're looking to change that and change the service, change the billing. And it's like $500 a year is what they quoted. It's like, it's just out of it. It's ridiculous. So the place we're getting it from, it was like $230 for 3 years. So it was very economical.
Anybody else? Do I hear a motion to adjourn? Anybody opposed? I took that as a motion. Beer was a motion. Thank you, everybody.
We're out of here.